Hello everyone. Before starting the lesson, try this warm-up. Bob wanted to solve for b. Here's b. He started but then gave up. Continue where he left off. Bob's work is in red, so all this stuff in red is what Bob started to do. There's no errors this time, he just didn't finish. So remember, the goal is to solve for b. You're started, so just see if you can finish this off. Pause the video, see how you do. When I solve for x, I do 36 multiplied by the sine of 42, and I get 24.1 meters. That's this side length. Now, also in the small triangle, if I want to solve for this side length here, y, I'll do tan 42 equals opposite over adjacent, x over y. Well, I know what x is. It's 24.1. So when I solve for y, it's 24.1 divided by tan 42, and that's 26.8 meters. Now that I know how long this section is, I can figure out how long this section is, labeled z. It's the entire length, 52 meters, minus the 26.8 meters that y was. And I end up with 25.2 meters. That's how long this part is. Now I can look in this big triangle. I know two sides. I can figure out the third using the Pythagorean theorem, and I get about 34.9 meters as the length of b. So this question recaps using the primary trigonometric ratios, sine, cos, and tan, and it also reviews Pythagorean theorem. Notice that I could not solve this problem using the sine law because I don't have a complete matching pair. B matches with the 42-degree angle, they're opposites. But this 36-meter side has no angle that we know of to match with, and this 52-meter side, we don't know what angle is up here to match with. So we couldn't use sine law to solve this problem. But if you do have a triangle like this, you don't have to break it up like Bob did and solve it using these 4 different steps here. There is an easier way to solve a triangle like this. If you can't use the sine law, we can use the cosine law. That's what this lesson is about. So we're going to determine missing side lengths and angles in oblique triangles using the cosine law. Remember, oblique triangles are just non-right triangles. And our goal is the same, find side lengths and angles. So if you can't use the sine law, meaning you don't have a matching pair of an angle with its opposite side, you have to use the cosine law. Here it is. C squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. If I rearrange this equation, it ends up looking like this. Cosine of angle C is equal to a squared plus b squared minus c squared, all of that divided by 2 times a times b. Now, it looks complex, but as you'll see in the examples, it's not really that difficult. All you have to do is plug numbers into the formula and use your calculator. The tricky part is just remembering what numbers to put where. Recall that angles, we use capital letters to represent them, and side lengths, we use lowercase letters to represent them. Sides, opposite angles have the same letter, just uppercase or lowercase. So here, when you see lowercase c and uppercase c, they're talking about a pair of opposites. Angle C is the angle that you know. Side C is the side length that is opposite to that angle. So the cosine law, written this way, is set up for you to solve for a missing side length. C represents the side that you're trying to calculate. A and B are just the other two sides of the triangle. And angle C is the angle that it's opposite to. If you're trying to find an angle, that's what we're calling capital C. It's important here that you're putting the opposite side where it says C. Remember, angle C and side C are opposites. So if you have an angle that you want to find, make sure you put the opposite side here where it says C. A and B are just the other two sides. It doesn't matter which one is which. Now this works with oblique triangles. It works also for right triangles, although for a right triangle, we just use the Pythagorean theorem if you know the other two sides. You don't have to do this part over here. Okay, so cosine law, here's the formula. Rearrange it this way to solve for an angle. Here's an example of determining the missing side length. So here we have an angle, and we know the two side lengths around it. We want to figure out how long the third side is. So x is across from the 57-degree angle, so those are opposites. So x is going in the C spot. That's the side we're trying to find. A and B are just the other two sides, so 14 and 10, and it doesn't matter which one you call A and which one you call B, as long as you just put them both in there, wherever you see it. So here A squared is 10 squared, B squared is 14 squared, 2 times A times B, that's 2 times 10 times 14. Make sure you put the same numbers in A and B as you did over here. Now the angle, remember, C and C are opposites, so x is opposite to 57 degrees. So you're going to put the 57-degree angle here. When you type this whole thing in your calculator, you should be getting this answer. Remember, that's what x squared is equal to, so if you want to find what x is, you have to take the square root, and you should end up with approximately 12 centimeters. I want you to try doing this in your calculator and making sure that you can get these answers before you move on to the rest of the lesson. If you're having trouble getting this, I can help you figure out how to type this properly into your calculator. Otherwise, we can move on to this example. Determine the length of side E, lowercase e. Well, here's angle E, so this is side E. We know the other two sides, and we know angle E. You can use the cosine law to solve for E. So pause the video and try to solve this problem. E is the side you're trying to find, so it goes here. 13 and 11 are the other two sides, so they go where A and B go in the cosine law. The angle 75 degrees is across from the side you're trying to find, so it goes here. Put this in your calculator, you get 215.9778 approximately. Take the square root, and you get about 14.7 centimeters. So this is a good example of how to use the cosine law to find the missing side length in a triangle. Now let's talk about finding angles. Here's an example. I know all three sides, and you need to know all three sides in order to find a missing angle. If I knew the two other angles, I would just have to subtract from 180, but because I don't know the other two angles, I have to use the cosine law here. This was the formula. Cosine of angle C is equal to a squared plus b squared minus c squared, all of that divided by 2 times a times b. Remember, angle C represents the angle we're trying to find, and we're calling it x, so I replace it with an x. The opposite side to that angle is 12, so it's very important that you put 12 where the C is. The other two sides, A and B, are just 10 and 14. Doesn't matter which one you call which, just wherever you see an A and a B, replace it with 10 and 14. Now, at this point, you could do this all in one step in your calculator. However, many of you will run into issues if you try doing that, because your calculator is going to follow the correct order of operations BEDMAS. So if you don't put brackets around your numerator or brackets around your denominator, your calculator is going to get messed up. So what I recommend is calculate the numerator separately from the denominator. So I would do 10 squared plus 14 squared minus 12 squared first, I get 152. I do 2 times 10 times 14, I get 280. And then you can divide and take the inverse cosine to find the angle. Just remember, if you're trying to find an angle, you have to do the inverse cosine as your last step. That's the same as when we were using the sine law. It's the same as when we were using the primary trig ratios. So here's another example. I have triangle PQR. I know all three side lengths, and I want to know what this angle is, angle P, which I'm using the symbol theta to represent it. Just remember, when it says solve the triangle, you're trying to find all the missing pieces. So we don't know any of these angles. We need to find out what they are. So solve the triangle. Pause the video and try it. I first started by solving for angle P. Because I don't have a complete pair of an angle with its opposite side, I have to use the cosine law. So this is how I did it. I got 34 degrees. Now that I knew an angle, I have an angle and its opposite side, matching pair, I can use the sine law, and that's what I did down here to find angle Q. Angle Q and 3.9 centimeters, they match up, so that's where this came from. Once I knew two angles, I could just subtract them both from 180 to get my third angle. So these are what I came up with. You might have solved this problem differently. You might have just used the cosine law the whole way through. Any way you do it, you should be getting roughly the same answers. And if you're up for the challenge, here's a question for you. Solve for theta. Theta is this angle here, angle P. Now this is not a one-step problem. You're going to have to think through this a little bit. So if you're up for the challenge, pause the video and see how you do. If you tried this question and you got 29 degrees approximately, then you're good. If you didn't, let me know so that I can help you figure out what the issue was. Otherwise, it's time to practice. You have a worksheet called Cosine Law Practice.